All right, so this question is a graphical question and a very important question. We will analyze it, but before we do that, read the question very carefully. It's a question about a parachutist who jumps from a plane, and we have to draw the graph of velocity versus time for the entire journey. So, read the question. I'll give you a few seconds to read the question, and then we will analyze the problem and start working on this solution. Okay. So I hope you have read the question. You have four choices. Read every word very, very carefully. I think especially the first few lines are of extreme importance. Okay. So I will just now start discussing the question, and what we will do is, we will start understanding the situation. So the situation is the parachutist jumps. And if you notice in the problem, the parachutist takes few seconds before he opens the parachute. Okay. So let's say you have this parachutist and he jumps off a horizontal. Okay. So he jumps off a horizontally moving airplane. The plane is moving horizontally, and of course, it will carry the initial velocity when it comes down. The Let's talk about the y-axis. Okay, let's talk about y-axis. When the parachutist jumps from this plane, okay, so that's your plane, for example. Okay, and he doesn't open the parachute for first few seconds. That means the first few seconds are essentially free fall. Okay, so first few seconds are free fall. And of course, if you notice in a real life situation, the parachutist is likely to face air resistance. Okay. You might have seen a lot of questions on projectile motion when it comes to air resistance, but this is another case of air resistance being applied on the parachutist. So say the air resistance comes into picture and it gets applied after few seconds, or as soon as you start falling, the air resistance will start, right? So you have parallelly air resistance, okay, air resistance being also applied on the parachutist, right? And then the parachutist comes down, okay? The parachutist also has a weight, which is the free fall, we are talking about. And there is a air resistance, and then it comes down, and then the parachutist, continues to fall with the help of free fall and faces air resistance, buoyant force, viscosity, and stuff like that, and then attains a terminal velocity, right? So it attains a terminal velocity, which is where at the point of terminal velocity, he is now going to open the parachute. I think this is something which is where you could do a mistake, right? So you could say that this is your terminal velocity and you open the parachute. So that's a point of parachute opening, right? So that's a point of parachute opening. If the parachute opens here, suddenly you lose velocity, right? Because you have some deceleration mechanism, and therefore your velocity comes down, and then it comes down, it comes down because of the parachute being there, and it again attains a constant velocity. Depending on how much distance you have, you still may fall with deceleration. The velocity is still increasing, but you're decelerating also. And the velocity is decreasing, not increasing when you're decelerating. So opening the parachute is very important. Where do you open the parachute? So if you read the question very carefully, I think this is left to the person who is reading the question, right? So it says that after a few seconds, he opens a parachute, right? There is actually no mention of what's happening. That has been left to our judgment, what's happening. So these are the first few seconds where you are, so let's say these are the first few seconds where you are, going without the help of parachute. And then from here on, you are moving with the help of parachute. So the velocity goes down from here. So if we analyze the question now, what we realize is this. Okay, and I will just so this is what is happening. So you have a situation of free fall, right? And the air resistance is low to start with because you still have the velocity as being low. Air resistance is directly proportional to the velocity. So initially your velocity is high and your air resistance is also high. As your velocity initially is low, it is increasing, and therefore the air resistance is also increasing until a point, the air resistance or the buoyant force or the viscous force, all of them balance out the weight of the body. So weight of the body gets balanced, you attain a terminal velocity here. And from here on, your velocity decreases, right? So here on, your velocity decreases. You continue to decrease the velocity and maybe you just come like this. If you now want to analyze the graph, okay, so initially you started, when you jumped, your velocity was 0. The velocity kept on increasing and therefore you see a variable acceleration. The slope of the graph, okay, is decreasing, and the slope of the graph here finally becomes parallel because now you've attained your terminal velocity, right? So terminal velocity, and then you have a opening of the parachute where your velocity decreases, okay? So let's see the choices we have in front of us, right? So if you notice, the graph number A is a correct graph because you see a drastic reduction in the velocity at the point of parachute opening. I think the trick in the question was, it wasn't a very difficult question. The trick was, where do you open the parachute and what is the implication of opening a parachute? Parachute, if you notice a real life situation, is meant to reduce the velocity. Otherwise, you will fall flat on the ground with a lot of speed, and therefore, understanding of how a parachutist comes down is very important in this question, which is graphical in nature. Initially, I thought the answer is A because the terminal velocity, that's about it. And if you just take this, which is your choice number B, as the answer, in that you're not opening the parachute. You're just, having a variable acceleration. Your velocity is not increasing at the same rate. It is increasing. There is an acceleration, but it shows a terminal velocity. It does not show a reduction in the velocity. So I think the choice number B is outrightly wrong. And if you notice choice number C, the choice number C says that you're starting with the velocity. Now, when you jump off a parachute, although you have a horizontal velocity, but I think the focus of this question is vertical velocity, right? So initially when you jump off, you have 0 vertical velocity in a horizontal moving plane. And if you notice choice number D, I think choice number D shows you the velocity becoming negative, which means you go up, as you open the parachute, your direction of the velocity probably changes. So I think, and it is wrong also because it shows the velocity to be, some value at t is equal to 0. So the correct choice is the choice number A. B is the correct answer if you don't open the parachute and you continue to move with the terminal velocity. So the terminal velocity could be so high that if you fall off, it may be dangerous. And therefore, you open the parachute, reduce the velocity, and so you can have those few seconds of luxury in a parachute to attain a terminal velocity and then open your parachute to reduce your velocity. So I hope this helped you. The whole concept was revolving around the fact that your initial velocity is 0 and the slope of the curve, right? The slope of the curve, had it been a free falling body, there was no air resistance, this graph would straight away go like this, right? It's a straight line graph. Continuously, the velocity will go up in the absence of the air resistance, buoyant force or viscous force. So some of this is inspired by the knowledge of fluids also. So I hope you like this solution. Thank you very much for your time. Please don't forget to watch my videos on mechanics. A lot of detailing a lot of discussion, a lot of conceptual orientation, a lot of categorization that will help you solve many such problems. Thank you very much for your time today.